Hello, everyone. Welcome to this unit where we will dive into an important concept in multi-table queries, the Cartesian product. Slide. Learning objectives. By the end of this unit, you will be able to explain the concept of the Cartesian product, identify and correct errors in multi-table queries that lead to unintended Cartesian products through hands-on practice. Reflect on what you've learned and apply these concepts to real-world queries. Exercise database. All examples and exercises in this unit are based on an order management database illustrated in the schema diagram. The database consists of 4 key tables. Customer table records customer information. Item table stores product details. Sales order table contains sales order data. Order line table tracks details of each product within an order, including the sales order ID, item ID, quantity, and unit price. Before we proceed, start your AI tool and local database. Import the schema diagram into the AI tool and inform it that you're learning SQL queries. Create the tables locally as per the provided instructions. These tables will be essential for practice problems throughout this lecture. Let's start with a problem. List the fields of items and their sales. From the schema, we know item fields are stored in the item table. Sales data is kept in the order line table. At first glance, retrieving all data from these tables might seem like the solution. But is it correct? Let's verify. 1. Run the SQL statement in your local database. If you encounter errors, collaborate with your AI tool to debug and resolve them. 2. Note about the number of rows returned. Is the result correct? To determine if the query is correct or not, let's analyze the data in the database. The item table has 10 items. The order line table has 14 sales records. A correct query should retrieve item fields by matching item P200 sales records to item P200 in the item table, item P202 sales records to item P202 in the item table, item P203 sales records to item P203 in the item table, and so on for the rest of the sales records. Therefore, a correct query should return 14 sales records with their item fields. But the query returned 140 records. What did go wrong? The SQL query contains several mistakes. 1. It listed only the order line table and the item table the from clause without specifying how they should be joined. 2. It assumed the database would automatically match rows using the foreign keys and primary keys. 3. It did not explicitly define a join condition in the SQL query. Without the join condition, the database performed a Cartesian product, pairing every row in one table with every row in the other. For this example, match item P200 with every sales record in order line table. Similarly, item P201 was matched with every sales record, even though it has no sales. This repeated for all 10 items, leading to 140 records instead of 14. It is called a Cartesian product or cross product of the rows of those two tables. To deepen your understanding, collaborate with your AI tool to 1. Explain the error in this query statement. 2. Correct the error by explicitly specifying a join condition. 3. Test the corrected query and confirm it produces the intended result. 4. Explore use cases where a Cartesian product might actually be useful. Let's summarize the key takeaways from this lesson. A Cartesian product matches every row in one table with every row in another table. By default, a Cartesian product occurs if a join condition is not specified when joining tables. To avoid unintended results, always define a correct join condition when working with multi-table queries. This concludes our lesson on Cartesian products in SQL. Thank you for watching and happy querying.